Hi, all right. Question one of the extra exam paper that I put together. This one's on coordinate geometry. By now, some similar questions in style to the ones that have come up. I think these are all previous WJEC questions. So, excuse me. The points A, B, and C have coordinates. These three here. The line L passes through C and is perpendicular to AB. So, as always, a little sketch, a rough sketch is probably a good idea. So, excuse my pen skills for this question. So, we have A, which is minus 7, 3, somewhere, let's say there. We have B, 2, 0, which is on the axes there. And we have C, which is minus 3, 5, let's say there. So those 3 points. The line L passes through C and is perpendicular to AB. So AB, let's join them up with a straight line. That's supposed to be straight, I do apologise. And there we have that one, which is perpendicular at 90 degrees. Find the gradient of AB. A, part 1, nice and easy. Y2 minus Y1 for X2 minus X1. And we're talking about A and B, so you're going to have 0 minus 3 over 2 minus 7, which is going to give you minus 3 over 9, which is minus 1/3. Part 2, show that the equation of the AB is that. Now, we're going to need y minus y1 equals m x minus x1. In this, we need a coordinate on the line. So for the equation AB, you can use either one of these first two. I'm going to use 2, 0. I'm going to use the coordinate B because this is 0, so that's going to make things nice and easy. And we also need the gradient, which we just worked out in the first part of the question. So I'm going to go for y minus 0 equals minus 1/3 x minus 2. It's all about now trying to get it into the form that it's in the question. So you get y equals minus 1 over 3x plus 2 over 3. Don't like the 3's on the bottom then, so I'm going to times through by 3. Y equals minus x plus 2. And you, 3y, of course, times by 3 on the other side. And then rearranging that, you're going to get x plus 3y minus 2 equals 0, what they have in the question. Find the equation of L. Now, L, remember, is this perpendicular line crossing through. So we need the perpendicular gradient, first of all, and we need the point, a coordinate on that line. And the coordinate I'm going to go for is the coordinate where the two lines meet. So our friend simultaneous equations. So part 3. First of all, the gradient. So gradient of L is the perpendicular one, which is 3. The coordinate where they meet is where I'm going to need simultaneous equations. Now, the simultaneous equation. Oh, what am I on about? Sorry, excuse me. It just occurred to me that I don't have that equation, but I don't need it because I am given that coordinate earlier on, which is coordinate C, which is on that line, obviously. So I'm just going to use that one instead. So it is y minus 5 equals 3 brackets x minus 3. So we get y minus 5 equals 3x plus 9. If we want the same form as the other one, we're going to end up with 3x minus y plus 14 equals 0. Part B. Part B, where am I going to do this? Let's go from there. The line L intersects AB at the point D. Okay, so this is the simultaneous equations part. Show that the coordinates are there. It's just that lovely phrase, show that, which is the answers given in the question, so that's good news. We have two equations of lines. We have this one, called this one number 1, this one number 2. Simultaneous equations, it's entirely up to you which method you go for. What I'm going to do is I'm going to rearrange equation 1 in the form x equals 2 minus 3y, and then I'm going to sub that into equation number 2. So I'm going to get 3 brackets 2 minus 3y minus y plus 14 equals 0. Other methods obviously available for this question. minus 9y minus y plus 14 equals 0. Minus 10y equals minus 20, so we'll get y equals 2, which is the coordinate in the question. Then I'm just going to go over here. We never do that really in an exam, just save space on this slide. I'm just going to sub that back into one of the equations. Let's go for equation number 2. Why not? And we get x equals 2 minus 3 times 2, which is, excuse me, minus 4, which is what it said in the question. Coordinates minus 4, 2. Part C. Show that L is not the perpendicular bisector of AB. Now, if it was the perpendicular bisector, then not only would it be perpendicular to the line, but it would also cut it in half. So basically what we're trying to prove is that this distance here is not the same as that distance there. Now, obviously in my exaggerated diagram, it probably doesn't look that. We can't just assume it. We need to find the lengths of the line. So we need to find the length of the line. Now, don't forget that this coordinate was called D in the middle. So we need to find the length of AD and the length of BD and prove that they're not the same as each other. Therefore, they're not equal and it's not a perpendicular bisector. So that formula with the old square root. So it's going to be minus 4 for D's x coordinate, take away minus 7 squared, plus, now we want the y coordinates of D and A, which are 2, take away 3 squared. That's a calculated job there, potentially. So, sorry, just doing this in my head, so that would be plus 3, 9, plus 1 squared, I guess root 10. Apologies if the mark scheme says something different. I just did that quickly in my head. And we also need the length of BD. Same sort of thing, but obviously we have different coordinates. So we've got minus 4 take away this time. The B1 is 2. Plus squared plus the 2 take away 0 squared. 36. So that is root 40, I believe, which is 2, 10. If you were to work that out. So therefore, you would say so a summary statement saying not equal. Therefore, it's not a perpendicular bisector. Part D. Find the value of tan ABC. Give your answer in its simplest form. Now, ABC. Now, if we were to connect, let's say that, and let's get rid of that one, and a better line than that together in the diagram, then you would, oh my goodness me, let's go for that one. That's a bit better, and I'll try and get rid of the separate one I did. Then we have a triangle. Tan ABC, that angle there, that is AB, that is the angle ABC. And we want tan of that angle. Now, obviously, we have a right angle triangle between B, C, and D. Now, tan would involve, well, let's go for tan A, B, C is its opposite over adjacent. Now, we don't need to do anything else other than just work out what the opposite and the adjacent are and put them into this fraction because it only wants tan ABC. Now, opposite is the side CD, and the adjacent is the side BD. So if I can work out the lengths of those two, I just put them in. CD and BD, now which seems very straightforward to me. I'm now sort of wondering why it is so straightforward, and hopefully I haven't done anything wrong because it's the last part of the question. Anyway, let's work it out. So CD would involve, the length of between C and D is where the coordinates given to us in the question. So it's going to be, D is minus 4, take away minus 3 squared. plus 2 take away 5 squared, all over BD. Length of BD. Oh, don't need to work that one out, do we? Of course not. We worked it out in the last bit of the question. So that's going to be 2 root 10 on the bottom. So on the top, I think it's root 10 on the top, over 2 root 10, and it wants it in its simplest form. Cancel out, cancel out. You're left with 1 on the top and half on the bottom. Okay.